Dear friends, welcome back to my YouTube channel MCB ChemTube. It's an online chemistry tutorial and you get my previous videos either from my personal homepage or from my YouTube channel. And in this lecture I am going to discuss with you the new topic organometallic compound. And we are going to discuss Grignard reagent and organolithium compounds and preparation and synthetic application. The learning objectives are to understand what is meant by organometallic reaction and preparation and synthetic application of Grignard organolithium, and later lecture I will discuss organozinc compound also. So what is meant by organometallic compound? And we have so far studied the reaction of this type when carbon is attached to n electronegative atoms, for example like alcohol, halides and ethers. The carbon get positive charge, that is carbon is electrophile. So usually these compounds react with a nucleophile and form the product like this. So suppose to make carbon react with an electrophile, what could happen? What should we do? That this to make it this carbon nucleophile. We have to make it this carbon nucleophile. So we have to attach this carbon with an less electronegative atom than carbon, that is metals. So in such cases, this carbon can act as a nucleophile and it can react with electrophiles. So carbon becomes nucleophilic when carbon is attached to a less electronegative atom than carbon, that is metals. So it can react with electrophile and it form a product like this. So organometallic compounds are the compound containing carbon metal bond. Example is organomagnesium, organolithium and organozinc compound. And in this example you can see the differentiation. This is the electrostatic potential diagram of alkyl halide and alkyl lithium. You can see that in here the blue-green part means it is less electron dense. The red part is more electron dense. In alkyl halide, this chlorine part is more electron dense. This carbon is less electron dense. And whereas in alkyl lithium, this part is red. Carbon is red. So it is more electron, having more electron density than lithium. And what about the type of bond in organometallic compound? And when carbon is attached to the metals like sodium or potassium, this is having very less electron density, you can see here, and this will be primarily ionic, largely ionic compound, and it is highly reactive. Sodium or potassium, it is highly reactive, it explodes even if you put in water. And when the carbon is attached to a metal like lead, tin or mercury, that is compared to this one, this is having higher electronegativity. So this will be primarily covalent. Then how about magnesium or lithium? When carbon is attached, this will be in between these two. That will be ionic, partially ionic you can say. So because of this ionic character, the reactivity usually depends on ionic character. When a bond is ionic, it will be highly reactive. So organomagnesium and organolithium compound are considerably ionic and highly reactive. And this carbon is negatively charged and this is partially ionic bond. So it can act as a strong base or strong nucleophile. And in organometallic reaction, what are the types of solvent usually used in reaction? Usually either solvents are used in anhydrous condition, that is very important. Either solvents like diethyl ether or cyclic ether tetrahydrofuran or non-polar solvent like hexanes are used. And how about the structure of alkyl magnesium bromide? Ethyl magnesium bromide. The magnesium satisfies its valency octet by complexing with the ether solvent. Usually Grignard reagent complex with the solvent. Magnesium here can accept electron from oxygen. So magnesium can act as a Lewis acid, here ether can act as a Lewis base. Next one, the preparation of organometallic reagents. First we will consider organolithium compound. Usually lithium metal is added to alkyl halide in non-polar solvents. That is alkyl halide or aryl halide with the two equivalent of lithium, presence of diethyl ether, it form alkyl halide, organolithium compound. For example, butyl bromide with lithium in presence of diethyl ether, and you get a very important synthetically very important reagent, normal butyl lithium. Similarly, if you use chlorobenzene, you get phenyl lithium. So the reaction conditions I told you is inert condition, should do either into nitrogen or argon atmosphere. It's highly reactive and most powerful organometallic reagent and widely used in synthetic chemistry. Next one, preparation of organomagnesium compound. It is was called Grignard reagent. It is the Victor Grignard. He discovered this compound and he synthesized first in this compound. He got Nobel Prize for his work. And usually it is done by the slow addition of halide into a metal suspension of magnesium. And for example, 1-bromobutane with magnesium, in the presence of ether, you get butyl magnesium bromide. Actually, this magnesium is inserted in between carbon and bromine, and it is an oxidative addition reaction. Here, the oxidation state of magnesium is 0. When it gets inserted, it becomes 2. So it is an oxidative addition. And you can prepare phenyl magnesium bromide by reacting bromobenzene with magnesium. Similarly, cyclohexyl magnesium bromide can prepare like this, and vinyl magnesium bromide can prepare by using the same method. Next one, reactions of organometallic reagents. First we will consider the reaction of compound with the acidic hydrogen atom. Acidic hydrogen atom like protic solvents, water, alcohol, ammonia. If you treat with this alcoholic solvent, protic compound, you get corresponding hydrocarbon. That is why we are not doing organometallic reaction in protic solvent. And it is a very strong base. It can act as a nucleophile. It can react with this electrophile and it forms RH. And this one is a stronger acid, not strong acid, stronger acid when compared to this weaker acid. This is pK value you can see here. This we can compare this to pK value. So you get the corresponding hydrocarbon. So it spoils actually this RMgX organometallic reagent in presence of protic solvent. Similarly, if you are using alcohol, it can react with the Grignard reagent and form corresponding hydrocarbon. Similarly, organolithium also can react with this protic solvent. It can give aromatic hydrocarbon. And the compound contains an acidic hydrogen like in alkyne. This is very weak acid, but it is stronger acid when compared to this base. So that is why this is also giving this reaction. So Grignard reagent can abstract this proton, okay, and it forms a corresponding hydrocarbon, and you get alkenyl magnesium halide. Okay. Similarly, organolithium compound also can form the same reaction and similar product. Next reaction is reaction with epoxides. It is also called oxirane and ethylene oxide. This is epoxide, oxirane or ethylene oxide. And this carbon is electrophilic carbon because it is attached to electronegative atom. So R can attack this electrophilic center, and this is highly strained, and this can break this bond and it form a complex like this. So R is reacting with this carbon, then RCH2, then this CH2, then O. Here the bond has broken, and it form a complex like this. After the completion of reaction, you can add aqueous acid and you get primary alcohol. For example, phenyl magnesium bromide can react with oxirane and form a complex like this, and finally you get this alcohol. And the same compound, if it react with unsymmetrical oxirane, where does this reaction occurs? And usually this nucleophilic center attack at less substituted position, that is this position, and here the bond will break and corresponding compound will be this one, complex will be this one. Okay, then corresponding alcohol you get. And next one, similarly, organolithium compound, methyl lithium, can react with oxirane like this, and it form a corresponding structure. Finally, it aqueous hydrolyzed to give alcohol. And next reaction is very important reaction with carbonyl compound. It usually provide alcohol. Grignard reagent with carbonyl compound, you get corresponding alcohol. And this is the second step. Finally, you have to aqueous hydrolyze. What is the mechanism? And this carbonyl compound, carbonyl carbon, this carbon is electrophilic center. It is positively charged and electrophilic center. So this nucleophile can attack this one, and this double bond break, and it form R can attach to this carbon, and it form a complex like this. This is the first step. Second step, aqueous hydrolysis. This by using aqueous acid, you can hydrolyze this complex into corresponding atom. So these are the beautiful example of carbon-carbon bond forming reaction. You can see that here the carbon-carbon bond is formed in the final product. Okay, and if suppose you are using formaldehyde in carbonyl compound, what would be the product? You are using formaldehyde, you get primary alcohol. So reaction with formaldehyde give primary alcohol. First you get corresponding complex. This is on hydrolysis. Finally you get primary alcohol. Here in this starter material you have a 2 hydrogen. That is why you are getting primary alcohol. Suppose you are using higher aldehyde, any aldehyde other than formaldehyde, acetaldehyde, propanaldehyde, butanaldehyde, you get secondary alcohol because you have only 1 hydrogen here. Okay, so you get secondary. So if you are using formaldehyde, you get primary, and any aldehyde other than formaldehyde, you get the secondary alcohol. So this is a wonderful example for making alcohol out of alkyl halide. And next one, third one, if you are reacting with the ketone, you get tertiary alcohol. And there is no hydrogen here, so you are getting tertiary alcohol. The reaction is same. Nucleophile react this carbonyl carbon and the bond, double bond break, and then form complex. Finally aqueous hydrolyzed to give alcohol. Next one, reaction with the ester. Also it provide alcohol. What is the difference in ester? First it react with ester like this carbonyl carbon. It attack the carbonyl carbon, the nucleophile, double bond break, and initially you get an unstable product. And this alkoxide is a good leaving group, and it form a ketone like this. It retain carbonyl bond by expelling this alkoxide. Okay, RO. and it forms ketone. And Grignard reagent is highly reactive. When you have another carbonyl here, it can further react with that carbonyl and it forms a tertiary alcohol finally, like we have seen in previous step. And these are the examples for this carbonyl reaction. If you are using phenyl magnesium bromide with the formaldehyde, you get finally benzyl alcohol. And if you are using ethyl magnesium bromide with acetaldehyde, you get a secondary alcohol 2-butanol. And if you are reacting, another example for a ketone reaction with ketone, butyl magnesium bromide with the acetone, you get a corresponding alkoxide complex like this. Then finally it get hydrolyzed to give this product. And reaction with ester, example for reaction with ester, ethyl magnesium bromide with ethyl acetate, you get corresponding complex. Then finally OET get expelled and it form a ketone. And ethyl magnesium bromide can further react with this ketone like we have seen in previous case, and it form a complex like this. Finally it get hydrolyzed. So this one you can see that the product is tertiary alcohol. Next one, reaction with carbon dioxide. It provide usually acid, phenyl magnesium bromide with carbon dioxide, and it form a complex like this. It is inert to further nucleophilic attack, this complex, and finally hydrolyzed. But there is a difference in the case of organolithium compound. Here the organolithium is more reactive than organomagnesium compound. So the initial complex formed will be further react with another equivalent of organolithium, and it form a ketone like this. So there is some difference in these two compounds. So I am giving one assignment. How would you carry out the following conversion by using organometallic reaction? And in summary, these are the versatile chemistry of organometallic compound, organomagnesium and organolithium compound. You can get variety of compound like hydrocarbon if you are using aqueous acid, and you get alcohol. If you formaldehyde, if you use, you get primary alcohol. If you use any aldehyde other than formaldehyde, you get secondary. If you use ketone, you get tertiary alcohol. And if you use ester, you get tertiary alcohol. With carbon dioxide, you get corresponding carboxylic acid. And with oxirane, you get alcohol. So that's all. Thank you for